These two galaxies are 11 million light years away, and I imaged them while I slept. I live in the Phoenix metro area, which is a very large metropolitan area with a huge population and tons of light pollution. We can't see that many stars naturally. Only the really big, bright ones are what are visible to us in our night sky. According to a publication by science.org, we are actually losing between 7 and 10% of the stars that we are able to see in the night sky every single year because of increasing light pollution. That is why it's absolutely mind blowing to me that we are able to get images from a very light polluted city, like the ones I showed you earlier, of galaxies millions of light years away. Let me tell you why and how. When you look through a visual telescope, you're only able to see the light that is hitting your eye in that given moment. But with the technology of new smart telescopes like the Seestar S50 and the Seestar S30 Pro that I'll be using tonight, they are able to collect the light slowly and then build it into a composite image that we're able to look at all at once. So it allows us to see significantly more detail in things like distant galaxies that we wouldn't otherwise be able to see. Even I often think about what it might have been like to be able to look up at the sky before all of the artificial light pollution that we have on our Earth today. It would be a fun experiment to travel back in time and be able to see what that's like. But with these telescopes, we are bringing the night sky back. And the crazy part is that we are traveling back in time, in a way, 11 million light years back in time, because that is how long ago the light that we are seeing left those galaxies and reached the lens of our telescope. To be clear, the collecting of all of this light and the stacking of it into a composite image is all handled automatically by the Seestar. So you don't have to know any complicated editing software or any complicated astronomy gear or anything like that. You just set these telescopes up and let them do their thing. They collect the light, stack it all together for you, and let you view the finished product. Now, I do just take it through some of the internal editing that you can do at the end of an imaging session, where you can adjust the brightness, contrast, saturation, and the crop. But those are just sliding bars. You just move to the left or right, very easy, very fast, and you are left with a really awesome image that is ready to go to share with your friends and family and on social media. What you're watching here is about an hour of light collection, sped way up so you can actually see it build in real time. And what's coming into view are two completely different types of galaxies sitting right next to each other in space. The one on the bottom is M81, also known as Bode's galaxy, a classic spiral galaxy, kind of like our own Milky Way. Hundreds of billions of stars organized into those smooth, structured arms. It's about 11 million light years away, which means the light you're seeing left that galaxy when humans were just beginning to spread across the Earth. And then on top, that thin streak is M82, often called the Cigar Galaxy. And it couldn't be more different. It's what's known as a starburst galaxy, where stars are forming at an incredibly fast rate, way faster than what we see in most galaxies. These two actually passed close to each other in the past, and that gravitational interaction likely triggered all those intense star formations in M82. So even though they look calm and still here, this is actually the result of a pretty dramatic cosmic encounter. By the way, if you're curious about what these lines are, stay tuned. We're going to talk about it more later in the video. Now, here's another quick time lapse of me handling some of the basic edits that you can do completely inside the Seestar app, not requiring you to use any outside editing software, before I reveal to you the finished product from the Seestar S50. This is the final edit of the image from the Seestar S50, and I did promise that I'd be shooting from both telescopes, the same target for the same amount of time. So here is the final edit from the Seestar S30 Pro. The first thing you should probably be noticing about the S30 Pro's image is that it has a significantly larger field of view. This is the field of view of the S50. Now go back to the field of view of the S30 Pro, and you'll see that it sees much more in the sky. As a matter of fact, the Seestar S30 Pro's image can see several more galaxies because of its larger field of view compared to the S50's. However, when we really zoom in on these galaxies from the image of the S30 Pro and the S50, there is more detail in the images from the S50. The larger aperture that allows it to collect a little bit more light does allow us to see more detail. But again, that larger field of view really comes in advantage sometimes with the S30 Pro, such as in this image here, where I was able to image the entire Orion's belt region. When I did this Orion Belt region, I did have to use something called mosaic mode, and we will have more videos about that in the future. I promised to talk to you about these streaks that we're seeing pass through some of these images. These are not shooting stars or airplanes, they're actually caused by satellites. And satellites are becoming a bit of an issue with many astronomers and astrophotographers. So many satellites passing through their images, especially professional level telescopes that are dealing with extremely sensitive data. With the thousands of satellites we have going up and all of the additional space junk, we often have things cut through our images like this. The good news is that the Seestar has an ability to detect when a satellite trail passes through the image, and it usually rejects it from the frame. So most of the time when we have a satellite pass through, it never even makes it into the image and you never see it. We just get one of those notifications that said that that image failed to be added to the stack. However, sometimes when these satellite trails are a little bit faint or dim, or the Seestar software misses it, it makes it into your image. But don't worry, they can easily be removed by increasing or decreasing contrast and brightness when you're handling the editing. Or if you use fancier post-processing editing software, you can remove the frames that have satellites in them as well. But they're really not a huge issue. The Seestar deals with them really cleanly, and they don't often show up in your final images. The exception to that being with the star trail images, which I've done another video on previously. By the way, if you love seeing content about space and learning more about the night sky and smart telescopes, please like and subscribe to see more.